Hi everyone! We are to solve this given oblique triangle. In order for us to solve this, we can use either the law of cosines or the law of cosines. But these formulas are dependent on what are the given measurements. For this given oblique triangle, we are to determine the three remaining angles here. We have measurements of each of the given sides. This is an example of an SSS oblique triangle, and we will be using here the law of cosines. In solving the measurements of the intended angle, let's try to label these sides here. Let's say this is A, and this 11 units is 7, B, and this is our C. This would also mean that the angles directly opposite these sides will have the same letter, though uppercase. This is your angle A, this is your angle B, and this is your angle C. In short, we are solving for the measurements of angle A, the measurement of angle B, and finally, the measurement of angle C. We do have formulas for this under law of cosines, but it's good to note that we will be using those formulas for only the first two angle measurements. The reason behind is that if we are going to use the formula for all these three angle measurements, we might commit an error as to determining whether it's a triangle or not pertaining to the triangle angle sum theorem. Because any triangle, according to triangle angle sum theorem, with all of its interior angles summed up, should exactly be equal to 180 degrees. If we're going to use the formula in solving for these three angles, we might come across with a situation where the sum of these three different angle measurements might be more or less than 180 degrees, meaning it will no longer be a triangle. So again, for the measurement of angle C, being the third angle to be measured, we will just be using the triangle angle sum theorem. For the measurement of angle A, we will be using one of the versions of the formula that is derived from the law of cosines, which would intend to solve the measurement of an angle. And that's actually using the arc cosine or the cosine inverse. And since we are measuring the angle A, the measurement of angle A, that's the side that we are subtracting here. In short, this is b squared plus c squared, and your denominator would contain 2bc. Let us try to extend a portion of this so that we could also try to automatically write the possible formula for the measurement of angle B using the same pattern. So it's still arc cosine or cosine inverse, and it's the b squared we'll be subtracting here. In short, that's a squared plus c squared all over 2ac. Now we can still come up with a formula for the measurement of angle C, but then again we will just be using the triangle angle sum to solve for the measurement of angle C. Now let's start with the measurement of angle A. We have the arc cosine or the inverse function of your b squared. You have 11 squared plus your c is 8 squared less your a 7 squared all over twice the product of 11 and 8. So we will be closing this and use the proper usage of parentheses so that our computation would not be too difficult to input in our calculator. Because my suggestion, when you're going to input this in your calculator, we will start with all of these entries here. This is the online calculator that I could share to you, and I would like you again to use parentheses to differentiate the expressions in the numerator and the denominator. So you have open parentheses 11 squared plus 8 squared less 7 squared. Close it. Then divide with an open parenthesis twice 11 and 8. Close it. Equals, that's your answer. Then we will subject this to the arc cosine or cosine inverse and answer and push equal sign. So you have 39.4005668, so on and so forth. Let's try to round it off into 2 decimal places, and by doing that, we will be approximating it to 39.40. 39.40. Now even if it's 40, we still write here 0 because it's a significant figure, significant digit, because we are rounding off into 2 decimal places. Simply close it with the degrees as a unit of measurement for angles. Let's proceed to the measurement of angle B. So you have here cosine inverse of the given measurements of A. You have 7 squared plus C is 8 squared minus 11 squared, that's your B, all over twice 7 by 8. So using the same calculator, moving it here, we will use parentheses of 7 squared plus 8 squared minus 11 squared. Close it. Divide by parentheses 2 times 7 multiplied by 8. Close it. Equals. No need to worry about the negative value here because you still need to subject that to this function. Answer, and you have your equals. You have 94.096, so on and so forth. Rounding it off into 2 decimal places, notice what will happen here. Measurement of angle B is approximately 94.10 now. It's not 0.96 because we are going to round it off. So the measurement of angle B is approximately 94.10. Still, the 0 is a significant digit. You need to place that because we are just rounding it off degrees here. Finally, for the measurement of angle C, we will just subtract the 2 solved measurement of angles from 180 degrees to assure triangle. Less 39.40 degrees minus 94.10 degrees. So we will have here the measurement of angle C is not equal, that's my bad, because even if you're going to subtract that here and you will have 180 less 39.4 less 94.1, and even if it looks like 46.5, take note that the 2 measurements that we subtracted from 180 are both rounded off values, so we still use approximation, and that's approximately 46.5. Approximately 46.5. Let's add 0 degrees. So these are the 3 measurements for the angles here in this given oblique triangle. Now, let's try to check whether they are actually correct using the concept of the side directly opposite your largest angle should be your longest side, and the side directly opposite your smallest angle be your shortest side. Here, our largest angle is B with 94.10 approximation degrees. So we could check here that B is your longest side, 11 versus 7 versus 8. And looking at your side measurements, side A with 7 units is your shortest side. It should follow that the measurement of angle A is your smallest angle, 39.4 versus 46.5 versus 94.1 or 10 degrees. So that's another hint that you could use in your future computations. So this is how we solve an SSS oblique triangle.